So today I'm going to take you through a couple of slides, but I think the most exciting part will be at the end because we have a demo that is going to come up. And I heard recently that it's pretty much the only live demo that is happening today. So you're in for a treat. So as a start, I just want to give you an overview of what InstaDeep is. So a lot of people always have questions like, what do you do? Because we do so many things. And so InstaDeep has two main verticals. We have the industrial optimization vertical. Some of the people here are actually working on that came here today. And then we also have the bio vertical. InstaDeep is a company that has been around for 10 years. We celebrated the 10 years recently in Tunis. It was actually born, the founders are from Tunis. And we do have offices now all around the world. We have Paris. So here, obviously, we have London, we have Cape Town, we have Boston, SF, and Kigali now. So we're all over the place. And we're more than 400 people now. And we do, like we said, a lot of research, a lot of engineering, and lots of different things. And the most important thing that happened last year was that we got acquired by BioNTech. So BioNTech is a company, for those of you who might have not heard of them, they were really famous in 2020 when they partnered with Pfizer to deliver the COVID vaccine. So they were behind the mRNA technology. And today they're applying this to the oncology space. So you'll be hearing a lot about them for a personalized cancer vaccine. So this is some of the work that BioNTech does, and they acquired us because we were supporting them during the pandemic with the AI work. And today we're supporting them with the oncology pipeline, the immunotherapy pipeline they have. And so I just wanted to give you an overview. So this is a little bit of the typical R&D pipeline. It goes from target identification all the way to functional validation. And so what InstaDeep does is support with AI tools that we integrate across the pipeline. So InstaDeep is fully in silico, so we only do AI work. And we partner with BioNTech to do the more lab work or the more applications work. And so we see here the nucleotide transformers are an example AI tool we've developed that we'll go into today. We also have Bayesian flow networks, super cool protein work, and it's a type of modeling framework that's generative, so generative protein design. And then we have here the assistants. The assistants are we merge basically the bio LLMs with the more natural language, so you can actually query these models with natural language, and you can ask them questions, and we're actually going to see this live in a bit. So I don't know if probably a lot of you already know what a foundation model is, but I just wanted to give you a bit of a summary. So foundation models, so you've heard about them in natural language, so you can gather all these types of data. You can create a foundation model through this pre-training, and then you can fine-tune it for many tasks. And so in our case, we actually do it in the biospace. So in the biospace, you can take multi-model data. In our case, we've taken genomic data, so a bunch of genomes, sequences. And we've gone through the process of pre-training in a similar fashion that people do in natural language. And we're creating these foundation models that we called the nucleotide transformer models. And then we fine-tune them for all these different tasks, like species classification, genome annotation, functional annotation. So a lot of different things that actually BioNTech and other pharma companies are really interested in, especially in the target identification stage at the beginning there. And so the models, we have actually made them available. So they're open source for non-commercial purposes. And the ones that are available are the ones that have been trained with different types of data. So we have the human ones, so Human Reference Genome, 1,000 Genomes Project, that's more than 3,000 samples we've trained with. And then we have multi-species, and we've also got edible plants. So we have a model just specifically trained with plant genomes. And then the multi-species one actually has bacterial genomes and other types of genomes all mixed into one model. We've trained them with different sizes. So these go from 50 million up to 2.5 billion, so super large models. And we've needed a bunch of different hardware. Some of the models have been trained in-house. We do have our own cluster where we train our models. And we also partner with NVIDIA and GCP to get all the resources. For example, here TPU v4. This actually requires really skilled engineers to know how to handle these and write code specifically for that hardware. And so we've have this kind of engineering expertise to be able to train these models with all these kinds of data, all this variation of sizes and lots of different types of hardware. I'm going to check the time here. So like we said, these models have been made available and lots of people have downloaded them. We currently have more than 700,000 downloads, which positions us as one of the most, usually it's the first or the second most downloaded model in the world in genomics AI, which means people have really found it useful, have leveraged these models for different use cases, and most importantly, we have been talking to them about the challenges that they've been encountering. One really big challenge is, right, these models are out there, and I can download them, but how do I run them? Because 1 billion, we saw 2.5 billion, like this kind of super large models, they're super difficult to actually run yourself. And one big challenge has been, how do I gather the compute resources to be able to run inference, just a simple inference? Another big challenge has been, how do I customize it? So obviously, these models have been trained with open source data and very general, like diversity in human genomes, for example, but maybe someone is interested in a specific use case with their own in-house data. And so how do I take my own data, process it, and then include it and fine-tune it with the models we've made available? And so these are some of the challenges we've seen. Another one maybe interesting is that it feels like the lifetime of these models is becoming way shorter. So we have version 1, version 2, version 3, all these models available, and it's super hard to keep up. And so we've also created tools like assistants that can help you just question like which models are available, what is the difference between version 1 and version 2 and version 3? Should I fine-tune version 3 or stick to version 1? And to be fair, I used to have these questions with the iPhones when they came out. Should I, upgrade to the next one? And now it feels like we have the same with LLMs. It's like, what should I go for? And so we've created tools to help you decide that. And this is what DeepChain is. So we created DeepChain out of these challenges that we've been describing. And what DeepChain really does is handle all the engineering for you. So you just need to select your model, and in the background we have teams of engineers that handle all the parallelization, making sure that we can deliver the results as fast as we can. And then it also allows you to customize the models for your needs. So we've created tools so that you can fine-tune it without having to know the specifics of the code or how the TPUs work. Like, we create very specific code to the hardware that we use to make sure it's fast enough and to make sure you can make the most of the training. And finally, like I was mentioning, we actually created these natural language interfaces so that you can ask simple questions, and it can help you go through the training yourself. I have a couple of slides left, and then we'll jump into the demo. I just wanted to show you really quickly, we've done a bunch of benchmarks to showcase the engineering behind this, and we've been able to improve, so compared to the Hugging Face open source version, we've been able to improve the speed of these inferences by 7 times and reduce the cost by twice. So this is just speaks to the engineering work behind DeepChain. So if you would like to use these models in production, especially we've seen that with BioNTech themselves, that if they want to use these models in a production setting, they need them to be fast enough and efficient enough. And this kind of speed ups is the kind of requirements that we've seen and we've been able to achieve with our engineering teams at InstaDeep. One last one, which I didn't have much time, but I always think this is super cool. When I heard of this, I was like, there's no way we did this. They basically took the largest open source model today, Llama 3.1, 405 billion parameters, and they fine-tuned it in-house. So that's basically what's behind our assistant. So they merged basically this kind of inferences with Llama with our own tool sets. They combined those into 2, and they created Layla. And Layla is the assistant that you can ask any questions. Behind we have Llama, but of course we also have the other tool sets that InstaDeep provides. And I think that's super cool because actually it requires a lot of skill set to be able, it's the same problem, right? You can access Llama, but to be able to run inference on this kind of model, you need to have the skill set to write the code, to be able to run it and get the resource allocation for it. So our teams internally have fine-tuned and deployed this model in-house. I'm going to be jumping into the demo now. I'll tell you when. So I do have to do a bit of typing, so I needed some support with the mic. But this is DeepChain. So DeepChain has 2 parts. One is the user interface, and the other one is the command line. So I didn't say this, but I'm actually a bioinformatician by training. I used to be coding in a sequencing company and working with lots of data, lots of different types of data, and I loved the different tools that I could sort of like install, like using the command line, Jupyter notebooks. I wanted the flexibility to be able to process my data and integrate tools into my workflows. And so that's why we created this kind of two options, one where you can visualize the models, and the other one where you can actually make the inferences using code. And so I'll start with the user interface. We've got the DNA models here that we were talking about, the nucleotide transformers. And for these, we have Segment-NT. Segment-NT actually has recently been quite valuable for multiple partners because with this model, so here you have some information about the data sets it was trained with, but essentially this model is able to, you give it a DNA sequence and it's able to tell you if you're seeing an exon, an intron. I actually don't know how much you know about genomics, but in a sequence, you have different elements that you can segment, let's say, and you can find promoters, enhancers, exons, introns, and so this model is a large language model that is that has a segmentation head. So it's actually leveraging a lot of knowledge from the typical computer vision models, and it's able to give you a segmentation of the sequence. And I'll show you how this one works live. Right here. Let me see, actually, could you help me here? Thank you so much. So this is, I'm switching now to the command line. So you can see here the deep chain models, so you can print them and see which ones are available. I wanted to show you how the Segment-NT works. Maybe I'll choose the multi-species one. And so here, if you want to run inference with the Segment-NT model, you can type deep chain run, you select your model, you give it an input data. So I actually compiled a bunch of sequences in a FASTA file earlier. I can show you after what they look like. And then I'm going to ask it to put it in a JSON file that I'm going to create. And I actually mistyped. Did I mistype? I actually mistyped the name of the file. It's sequences. Sorry. Okay, so now it's actually being sent. I think that's it. Thank you so much. So now we actually send the request through, and it's processing. And so what we're hoping to get here is the sequences I sent, which I could even show you in a second. I think I sent over 100 sequences. They have their gene ID, and then you see the typical AGTC sequence. And now what we're hoping to receive is the results showing you the probability that each of these letters, ACTG, belongs to one of 14 categories. These 14 categories are introns, exons. Oh, here it is. So here it is. So protein coding gene, 0.29 probability that this specific base pair, this specific letter part of the sequence belongs to this category. And so this is quite helpful actually for bioinformaticians when they have their workflows and they're trying to identify which part is actually a protein coding and which part is not. And they have these results available in a JSON file. This is for one gene, and then you have the annotation probability for each base in each of the genes. So that's one example for you there. I'm going to put it back. And then I want to show you the fine-tuning. I have 1 minute and a half left. But I really want to show you quick. So we have the fine-tuning feature here where you can start a fine-tuning run. You can select your base model. You can put, I'm going to put just test 3. And then you can select your downstream task. You need to have your data already prepared. So in my case, I prepared a couple of FASTA files and some paired CSVs for the label. So you always need a sequence and then its label, right? And if you do a gene expression task, you'll have, I think in this case, I have a sequence, and for each gene, I'm giving it the label of what is the gene expression for different tissues. So for the same sequence in different tissues. That's more technical in the biospace. And then I'm going to put the validation data here. Then you can change your parameters, so batch size. You can play a bit around with it. And what this does is it uploads the data, and you can keep track of the runs right here. So I'm just going to show you quickly. I think this is the one we started. And you can keep track of the training live. So you're able to see how the loss is going down, hopefully. So in a training, you want the loss to go down, R squared to go up, hopefully. And you can keep track, and you can create new models based on our own models. And then you can quickly make inference like the one we did here. So in the command line, you could save the model, and then you could run it here the same way we did in the command line and see if your results are improving. And this is an experimentation tool that you can use as much as you want. And one final thing, I'm just really sad because I didn't get time for this, but so you can basically, so this is the assistant. You can use Layla to ask any questions, like, for example, let me see, what models do you have? Hi, thank you. For DNA analysis. So this is quite a simple question, but it's essentially giving you all the lists that I showed you in the command line. And now what I could do, if I had more than 5 seconds, I could show you that it can do the inference for you. So I could just say, this is my sequence, so I can attach the sequence. This is my sequence, and then it gives me the probabilities in a more user-friendly way. You can visualize it, so it's just a different way of getting your output. It's just maybe I started with this because I love this. It shows that you can integrate it into workflows, but if you're just starting, you could just use the assistant itself. So I think that's it from my side. Thank you so much.
Thank you.